All right, let's dive right in. Every single atom in the universe has a unique fingerprint, and it's all defined by just two numbers. If you can get these two numbers straight, you've basically got the secret decoder ring for the entire periodic table. So let's get into it.
So it really all boils down to this one question, right? What actually makes a carbon atom? Well, carbon, and not oxygen, or gold, or hydrogen. Turns out, every single element has its own personal ID card, and today we're going to learn exactly how to read it.
Okay, first up is the big one, the number that defines what an element is, its identity. We're talking about the atomic number.
So what is it? Honestly, it's super simple. The atomic number, which we label with a Z, is just the count of how many protons are crammed into the center of an atom, into its nucleus. That's it.
Think of this number like a social security number for an atom. It is absolutely unique, and it tells you exactly what element you're dealing with. No two elements share the same one. And hey, here's a little bonus. If you have a neutral atom where all the charges are perfectly balanced, that atomic number also tells you how many electrons are zipping around the outside. Pretty neat, right?
Let's make this real. Take carbon. Its atomic number is 6, and that is completely non-negotiable. Every single carbon atom that exists anywhere in the universe has exactly 6 protons. Not 5, nope, not 7, always 6.
And that right there, that's really the golden rule of chemistry. The number of protons is set in stone. If you find an atom and you count 6 protons, boom, you know without a shadow of a doubt that you are looking at carbon. If it has 8 protons, it's oxygen. It's the ultimate unchangeable identifier.
Okay, so we've got the identity locked down. Now let's switch gears and talk about the atom's weight. To do that, we need our second key number, the atomic mass.
Now, the definition here is also really straightforward. You'll hear this called atomic mass, or sometimes more specifically, the mass number. We label this one with an A, and it's just the total count of the heavy stuff in the nucleus. That means you add up all the protons and all the neutrons together.
And the formula for it is exactly as simple as it sounds. You want to find the mass number? You just take your number of protons, add the number of neutrons, and you're done. Simple addition.
So the key thing here is that this number tells us about the mass of the atom's core, its nucleus. But wait, I know what you're thinking. Hey, what about the electrons? Well, here's the thing. Electrons are so incredibly, ridiculously light compared to protons and neutrons. It's kind of like weighing an aircraft carrier and then worrying about the weight of a seagull that lands on it. You just don't. Their mass is so small, we basically ignore it for this calculation.
Let's go back to our old friend carbon. We already know it has to have 6 protons. That's its ID, remember? Now, the most common type of carbon, the one you run into most of the time, also has 6 neutrons. So you do the math, 6 protons plus 6 neutrons gives us a grand total, a mass number of 12. Easy as that.
Okay, so we've got both our numbers. Now let's put them side by side, a little head-to-head comparison, just to make the difference totally crystal clear. This table just lays it all out perfectly. Look at that first row. What does atomic number count? Protons. Only protons. What about atomic mass? Well, that counts both protons and neutrons. Then look at the second row, because this is the real takeaway. Atomic number determines the element's identity. It answers the question, what are you? But atomic mass? That just determines its mass. It answers, how heavy are you?
And if you want a really great way to remember all this, just think about this quote. Atomic number defines the element. Atomic mass defines the version of that element. So the atomic number tells you you're looking at carbon. That's the element. The atomic mass tells you which kind of carbon it is. It's a specific version.
All right, so you might be asking yourself, okay, I get it, but why do we care so much? Why does this distinction really matter?
Because honestly, this isn't just a bit of trivia for a test. Getting this right, knowing the difference between atomic number and atomic mass, is the absolute key to unlocking the entire periodic table. It's the basic language of chemistry. You really can't go anywhere in chemistry without totally getting this concept down first.
And that leaves us with a really fascinating final thought. We've established that the number of protons is fixed, right? It's sacred. You change it, you change the element. But what happens if you fiddle with the number of neutrons? You'd still have the same element, but it would have a different mass. These different versions of an element, well, they have a name. They're called isotopes. And that's a whole other fascinating story. Thanks for diving into this with me today.